Welcome back, friends. Today let's continue our discussion on the states of matter by discussing the Graham's law of diffusion or effusion. So Graham's law inakuwa inazungumzia kama tuna gesi mbili au zaidi, lakini zile gesi ziko within a container na zile gesi they do not react. Principle inayotumika hapa ni ile kama kwenye Dalton's law kwamba gases must not react. So when two gases are placed in contact, they mix spontaneously. This is due to the movement of molecules of one gas into the other gas. This process of mixing of gases by random motion of molecules is called diffusion. Now Thomas Graham observed that molecules with smaller masses diffuse faster than heavier molecules. Kwa Graham's law wenyewe ina suggest kwamba rate ya diffusion ya gas molecule itategemea kwenye nini? Mass ya hizo molecule. Now in 1828 Graham formulated what is known as Graham's law of diffusion. Now the law stated that under the same condition of temperature and pressure, the rate of diffusion or effusion of different gases are inversely proportional to the square root of their molecular masses. So rate is inversely proportional to the square root of molecular masses, MR. This is what we call as Graham's law. Graham's law. Au kwa njia nyingine unaweza kusema the rate of diffusion or effusion of a gas at given temperature and pressure vary inversely proportional to the square root of their densities. So R square root of density. Any of these is the Graham's law. Either ukisema molar mass au ukisema density ni kitu kile kile. So Graham's law, from Graham's law, R will be equal to K divided by square root of molar mass. So R times square root of molar mass will be equal to K. R1 square root of molar mass 1 is equal to R2 square root of molar mass 2, which will be equal to K. So R1 square root of molar mass 1 is equal to R2 square root of molar mass 2. R1 divided by R2 is equal to molar mass 2 divided by molar mass 1. That is the equation representing the Graham's law. So when the gas escapes through a pinhole into a region of low pressure of vacuum, the process is called effusion. Kwa effusion lazima gesi inapita kwenye small pinhole, lakini diffusion sio lazima kwa kuna small pinhole. Thus, diffusion and effusion can be defined as follows. Diffusion is the spread up of gas molecule or particles in space from region of higher concentration to region of lower concentration. That is diffusion. Spread, kusambaa kwa gas molecule. Or is the mixing of gas molecule by random motion under condition where molecular collision occur. Lakini effusion can be defined kwamba effusion is the escape or movement of material from a container through a small hole aperture, or is the escape of a gas through a pinhole without molecular collision. So in effusion there is no collision, while in diffusion there is collision. Kwa hiyo kwenye Graham's law kama nilivyokuambia kwamba unaweza kufika hapo, au tunaweza kusema pia R is inversely proportional to the square root of density. So R times the square root of density will be equal to K. R1 square root of density 1 is equal to R2 square root of density 2 is equal to constant K. So tapata R1 divided by R2 square root of density 2 divided by density 1 This will be the expression for Graham's law. Kwa hiyo ukitoka hapa sasa, kwa mfano ukaja ukasema hivi, from R is equal to 1 divided by square root of density. Square root of density. R1 divided by R2, square root of density 2 divided by density 1. Now from ideal gas equation, from ideal gas equation, R1 divided by R2, R1 divided by R2 tapata sasana. Ideal gas equation, PV is equal to NRT. From there, N is equal to mass divided by molar mass. PV is equal to mass divided by molar mass, RT. P is equal to M divided by V, RT divided by molar mass. But M divided by V is equal to density. PV is equal to density, RT divided by molar mass. Density is equal to PV, MR divided by RT. So keeping this as constant, density is directly proportional to the molar mass. Or sometimes tufanye density 1 itakuwa sana PV subtraction of volume molar mass 1 gawanya kwa RT. Density 2 itakuwa sana PV molar mass 2 gawanya kwa RT. Tukija kuinsert kwenye equation ile pale, tutakuja kupata R1 divided by R2 is equal to square root of molar mass 2 divided by molar mass 1. Na hiyo itakuwa ndo equation ya Graham's law. Itakuwa equation ya Graham's law kama unaweza kuona. So tunavyo define rate kwenye Graham's law, rate inaweza ikawa sana volume of a gas or length of diffusion. Diffusion divided by time. So simply rate is equal to something divided by time. Ituseme rate. So kwa mfano rate 1 inaweza kuwa sana volume 1 divided by time 1. Rate 2 inaweza kuwa sana volume 2 divided by time 2. So kumbe tutakuja kuona ni tukichukua labda rate 1 divided by rate 2 itakuwa sana volume 1 divided by time 1 times time 2 divided by volume 2. Rate 1 divided by rate 2, volume 1, T1, T2, volume 2. You see, that is Graham's law. Hivyo ndivyo ambavyo ipo. Kwa hiyo kama rate 1 divided by rate 2, let's say hapa volume ya gas ni ile, normally volume ya gas ni ile. So volume, if V1 is equal to V2, rate 1 divided by rate 2 will be equal to T2 divided by T1. Tukirudi kwenye equation yetu, rate 1 divided by rate 2 is equal to density 1 divided by density 2 square root. Tukiequate equation hii na hiyo hapo tutakuja kupata T2 divided by T1 is equal to density 1 divided by density 2. Kwa hiyo I'm ending up here. Lakini video inayofuata tutaangalia worked examples. Kama umenielewa hapa na mimi kwenye worked examples za video inayofuata tutaelewana vizuri. Don't forget to subscribe and share the video to your fellows. Ili tuweze kujifunza pamoja states of matter. Thank you.